All right, so today we are finishing this very short chapter, chapter 9, by talking about square root equations. So our goal today is to solve equations using square roots. So the first bullet point, remember you only had to write down the third one, but the first one, we'll read through it anyway, says, remember, we solve equations by undoing whatever is happening to our x term. So if x is being like multiplied by 3, we would undo that by dividing by 3. Or if you were adding a 2 to the x, we would undo that by subtracting a 2 from the x. Those are called inverse operations. That's what we spent a whole bunch of time working on last fall, chapter 2 stuff. So we would try to get x by itself by undoing whatever was happening to the x. Today we're going to look at equations where the x term is being squared. And the inverse of squaring something is taking the square root. That's what we learned how to do yesterday. So when solving these types of equations, so we're only talking about equations with an x term, or sorry, an x squared term, no x term. So not like the GCF or the MA method from last chapter, how there was an x squared and an x. There will only be an x squared today. You get that x squared by itself, make sure it's all alone on one side of the equal sign, and then you take the square root of both sides. That's how we're going to get the x by itself. Do you have any questions so far? So, this is just a practice problem before we get into actual examples. So this is not example 1. Example 1 is after this one. Remember, when you are solving an equation, you're trying to find out what makes the x part true. Like what you could plug in for x and get a true statement. So this is basically asking you, what number would you square to equal 9?
3.
Okay, great. If you didn't know that, you would take the square root of both sides. That's how you undo squaring the x. You take the square root. So that would leave me with x, because x squared, take the square root just as x. The square root of x squared is x. Equals, and you guys all said that the square root of 9 is 3.
So you just put x.
Think back to our warm-up though. Is there another number you could plug in here, square it, and still get a positive 9? Is positive 3 the only number that you can square and get positive 9? Yeah, if you put a negative 3 in there, negative 3 times negative 3 is still positive 9, right? Everybody with me? The way we show that is using this symbol right here. Plus or minus 3. That means you could plug a positive 3 in, and it works. You could plug a negative 3 in, and it works. Does this look familiar to anyone?
Yeah, so we just.
When did we talk about something like this? Chapter 8. The section about the dots problems. Remember, difference of two squares? So let me show you something off to the side. And you don't need to write this down. I just think this is kind of cool to look at. What would happen if I wanted to put the 9 over here? What would I have to do? I could just subtract it, right? That would leave me with x squared minus 9 equals, and then over here I'd have a 0. Is this something you know how to find the answer to? X plus 3, x minus 3. Set them each equal to 0 and solve. Is this ringing a bell? A lot of you did very well on this part of the test, the difference of two squares. Our solutions last chapter when we did this problem were positive 3 and negative 3. Holy cow, it's still positive 3 and negative 3. Isn't that amazing? So a lot of the problems, especially when they're perfect squares, you already know how to do them. We just did them in a slightly different form. We wanted to use the zero product rule, so we set it equal to 0. But it's the exact same problem. It's the exact same solution. Today we're doing it in a little bit quicker method. We're just taking the square root of both sides. Okay, so I have x squared equals 24. I want to know what x equals. So what do I need to do to both sides of the equation? You can simply just take the... How do you undo squaring something? That's what we learned yesterday, what this entire chapter is about.
You do the parentheses, then you do the XX, then you do the...
That...
No, if that's square root.
Yeah, we're going to take the square root of both sides of the equation. The square root and the squared undo each other. And you're left with just x equals, but remember, we're going to use the plus answer and the minus answer. We're going to look at the positive answer and the negative answer. So every single problem, every single solution, you should have this symbol in it, plus or minus. It means whatever our answer is, the positive value works and the negative value works. Because remember, when you're squaring it, a negative times a negative, you still get a positive. So don't forget your plus or minus sign. Now, is this a perfect square? No. So off to the side, I'm going to do a little factor tree for square root 24. Any ideas?
Okay.
3 times 8? Okay, 3 is prime. 2 times 4, 2 is prime. 2 times 2, 2 and 2 are both prime. So who's coming outside?
So,
These twos, right? So they're escaping. They've partnered up. They're teaming up together. They're breaking out of that radical. So out front, right after that plus or minus, I'm going to have a 2. Now, there are 2 numbers left inside the radical. What are they? 2 and 3. And what is 2 times 3? 6. So my answer is x equals plus or minus 2 times square root 6. And you might be saying, well, how do I know if this is right? Grab a calculator, type it in, 2. There's a radical button. Then it will open up a set of parentheses. Type in a 6, close those parentheses, and square it. And you should end up with 24. You might have to add another set of parentheses. I might have lied to you there. So it knows you want to square the whole thing. But that's how you can check your work, to type it in the calculator. So I have x squared equals 75, and I want to know what the x equals. So what am I going to do?
You gotta do that little thing.
Do that little thing.
Yeah.
This little thing?
Yeah.
Yeah, that's called taking the square root. You're going to take the square root of both sides. The square root of x squared is just x. Equals, anytime you take the square root of both sides of an equation, you have to think of the positive solution and the negative solution. So you need that plus or minus sign. I always put the plus or minus sign before I do anything else so I don't forget it. Don't get lost in your factor tree and then forget the plus or minus because you're so excited about your answer. Just put it right up front. Plus or minus. Boom. Is 75 a perfect square? No. So let's do a factor tree. 5 and 15 will work. 3 and 5 will work.
what about
Here's a pair of 5s. They're going to break out together. So what goes right next to the plus or minus?
5?
A 5. They broke out. They became 1 5. Here it is. What's left over? The 3. To solve this equation, what do I need to do to both sides of the equal sign? Take the square root. Very good. What's the square root of x squared? X equals, what goes next? Plus minus. Is 32 a perfect square? No. So off to the side, I want you to figure out
2 and 16.
what simplifies from this radical. What do you do? 2 and 16, okay? 2 is prime. What about 16? 4 and 4, good. Each 4 breaks up into 2 and 2. 2 and 2. So these 2's and these 2's. So how many 2's do you have in the front of your radical? 2. And 2 times 2 is? 4. And what's inside the radical? 2. Very good. Box it in. What are your questions? All right, I have x squared equals 4. What do I need to do to both sides of the equal sign? Take the square root. What is the square root of x squared? X equals, what do I put immediately?
4.
Immediately.
Oh, it's
Plus minus.
Plus minus, very good. Is 4 a perfect square?
Yes.
Yes, so what is the square root of 4? 2. Very good. So positive 2 squared is 4, negative 2 squared is 4. When this number is a perfect square, these are very, very easy. This is like the kind we could have done in the last chapter if we wanted to use dots. You'd still get the same answer. But it's a lot easier to just take the square root, so that's what I recommend. It's when they're not so perfect squares is when you have an issue. What are your questions on the perfect squares? All right, here's one more not so perfect square, then we'll do one more perfect square, and then you guys can start on your homework. So x squared equals 72.
Oh,
What should I do to both sides of the equal sign? First I need to put the little thing, this thing? Square root, radical, root. All of those are interchangeable terms. Okay, and then the square root of x squared gives you what on the left side? Just x equals plus minus. You got to think of the positive and the negative.
5 square root 3.
That's if it was 75.
Okay, it's 75.
This is 72, so we gotta.
No,
We could do 8 and 9.
that's wrong. You should have said.
You could do 3 and 24, I think, right? Lots of different ways to get there, but you should end up with 3 2's and 2 3's. So who's breaking out? The 2's and the 3's. So I'll have 1 2 and 1 3. What's 2 times 3? 6. And then square root 2, because this lonely 2 did not get a partner. Boo-hoo. What are your questions? Any questions at all? All right, last problem of the notes for today, and then I'll let you go on your homework. We have x squared equals 36. What should I do to both sides of the equal sign? What's this called? Square root. Take the square root of both sides. You get x equals what? Very good. 36 is a perfect square. It gives us plus or minus 6. Raise your hand if you have any questions.